Hello everyone, we're going to be doing number 40, an enzyme catalyzed reaction carried out in a solution buffered with 0.03 molar phosphate, pH 7.2. As a result of the reaction, 0.004 moles per liter of acid was formed. A. What was the pH at the end of the reaction? I'm only going to do A because that was all that was requested of me. And B and C should be fairly able to do if you've been able to make it this far. So, how do we start this one? Well, we're going to start off with our Henderson-Hasselbalch equation, which is going to be we're going to look at this one. Now, if we look at the page 39 in the Gary Grisham, we notice that the pKa is 7.2. Let's draw our phosphate group. So this could be H3PO4 going to H2PO4 minus going to HPO4 minus 2, and this is PO4 minus 3. This right here is 7.2. Okay. This right here is going to be 2.15, and this is somewhere in the range of 12. So these two are so far away that we're not going to care about these two compounds. We're only going to focus on these. Now, if we look back at our equations, we notice that pH equals pKa when conjugate base equals conjugate acid. What does that mean? That means when pH equals pKa, this amount is equal to this amount. So that means half of this and half of this currently. So our pH is 7.2. Our pKa is 7.2. So that means that 0.03 moles, and this is moles per liter, but we're just going to assume it's 1 liter just to make everything, this is molarity, right, which is moles per liter. But I'm going to assume that the total volume is 1 liter just to make everything simple. So we can have 0.03 moles. You can divide this by 2. And this is going to give us 0.015 moles of our base and 0.015 moles of our acid. Acid, base. Now, what we're doing is when this enzyme catalyzes this, it makes 0.004. I think that's right. Let me double check that number. Zero zero four, yeah. Makes 0.004 moles of H plus. So what does that mean for us? That means 0.004 moles of our base right here is forced over here. So now we have a different equation here. Now we're going to have our pH equals something. pK is still 7.2. If 0.015 minus 0.004 just gonna give us 0.011 of our base. And then we're going to add on 0.004 to this. So now okay. So what that means is that this right here is our start. And this right here, these two is our finish. It's always important to recognize what you start as and what you finish as. Right? So this right here is going to be our conjugate base over our acid. We can think of it as a products over reactants. 0.011, 0.019. Sorry, I got something caught in my throat. So after this whole term right here is going to equal negative 2.37. Or I'm sorry. Not 2 point, that's silly. It's going to be 0.237. Alright. Figure this out. pH is going to equal 6.96. And that's your answer. To do part B, it's very simple. All you're going to do is that instead of adding this acid to how much acid is produced, you gotta add that to water. But water adds only contributes 1 times 10 to the negative 7th. This is times 10 to the negative 3rd. So this is going to be a lot more. So you're just going to take the negative log of this, and that's going to give you your final pH of what happens when your acid isn't there. So hopefully that was pretty easy to understand, and see you next time.